Welcome to Zig for the Uninitiated. My name is Tyler. Let's get started. Today I want to start talking about comp time and Zig. And if you've been anywhere around Zig or been reading about Zig and learning about Zig, you would understand, or you probably know, that comp time is a big deal for Zig. It's one of the big defining features of the language. And I want to make an introductory video, and hopefully this will be a series of a few more videos about comp time and what it means and how it's used in Zig. But before I got into that, I'd like to talk about what we mean by comp time, and in general, what compile time and build time and runtime are. I think some of those maybe are a little self-explanatory, but I want to give a good explanation of it, because I think once you have that understanding, it can help get you in the right mindset when you think about comp time. So here I have a chart of what I call the temporal periods of a program's lifetime. So on the what we could call the y-axis here, on the left-hand side, we have what I consider three kind of sections of memory or data around a program. And then on the x-axis, what we call time, we're going to have different gates. And those gates are going to kind of define when these different times begin or end. And so first, starting with our data, when we are, as developers, writing a program, we are able to modify the program in different ways. And we're able to modify that program in different ways to then behave differently. And where we're able to modify that program and when we modify that program is what we mean by these three temporal periods of a program's lifetime. And when I say we, that's me. I don't know if I came up with that name, but I'll take credit for it because it's pretty bad. All right, let's talk about the three data sections, we can call them, I guess, of a program and how they're affected. And so I want to start with executable, or the binary. Now, we might not often think about the executable as data, but it is. When you load an executable, when you run an executable, that executable's code, the machine code, is loaded into memory and it's run. It is data. And we're able to modify that by writing different source code, but also by directing the compiler to behave in different ways or treat the source code differently. And that is what we mean by compile time. Some examples of what you can do in Zig and in some other languages at compile time are reflection, generics, conditional compilation. Basically, anytime that you write code in a way that generates different machine code, that is going to be compile time dynamics. Then you have build time. And build time is very closely associated with compile time, because when you build your program, you are inherently compiling it as well. But I like to think of build time as a superset. Whereas compile time is everything that the compiler has to do to generate the machine code for your program, build time, or your build system, your build process, is everything that you need to do to not only generate the compiled executable, but any assets, anything else around it. So, for example, if you're building a game and you have a lot of graphic assets that you need to generate or build or package in different ways, that can happen as part of build time. It's not actually going into the executable, but it's data that will eventually be shipped with your program. Then once the code is shipped, that's it. You can't affect what those assets look like until you ship code again. So that's what kind of involves build time. And then finally, you can see we have this gap between when the code is shipped and when the program is actually executed. And that, once the program is executed, is what we call runtime. That anything that happens on the stack and the heap and process memory that manipulates the data, right? The way that our executable interacts with the stack, the heap, and the process at runtime, that is all runtime dynamics. And so classic example of that is going to be stuff that user inputs, the way we react to user input, the the way we allow a user to configure the program, that's all runtime information, and it's runtime dynamics. That is kind of a brief overview of, once again, what I call the 3 temporal periods of a program's lifetime. If you've got a better name for it, or if there is already an existing better name for it, please let me know. I think it's not a great name, but it's the one I came up with.